Hey guys, what's up? I'm going to be solving another paper with you guys today. It is actually 9702 physics paper, winter 19, question paper 1 and variant 1. So this is actually MCQ paper, and yes, this is a request by the student that the paper is actually difficult, so I'm going to be solving this paper. For which quantity is the magnitude a reasonable estimate? The frequency of the radio wave is given way too low. If you look at this value, this is picohertz. Picohertz means it is a very small value. Apparently this cannot be true. So the first one is something that I'm just going to be ignoring for the time being. Let's just look at this thing. Mass of an atom is actually going to be much smaller than this. So this is also not true. This is microgram. The Young modulus of a metal should be in the range of 10 raised to power 11. So this cannot be true because this is actually 5 into 10 raised to power 3. This is going to be 10 raised to power 5 Pascal. This is way too small value. So this cannot be true as well. But let's just look at this thing, the wavelength of green light. As I said earlier, this is a table that needs to be memorized. This is the table that I'm going to be using. You can look at the visible region. This is actually from for 400 nanometers. You can just read it like this. This is actually 400 nanometers to 700 nanometers. Okay. So this is the range of visible region. So this, as we are supposed to just find an estimate. So wavelength of green light does make sense. It is given in nanometers. Actually, I've just used the wrong symbol for nano. This has to be small. So remember this thing, nano needs to be represented by a small n over here. Anyways, the speed of waves in a deep water depends on its wavelength L and the acceleration of the free fall g. What is the possible equation for the speed v of the wave? Okay, so the thing is, this question is about homogeneity of equations. So we are going to be working on the units over here. So if we look at option number A, this is actually, I'm just going to ignore the constants over there. These are the constant and they can be ignored completely. Okay. So we are not going to be focusing on the constants over here because these are dimensionless quantities. Anyways, so G stands for the acceleration due to gravity, which is ms minus 2. I'm just working on option A first. So ms minus 2 multiplied by length is actually m. And if we multiply the two together inside the brackets, that is going to be, I'm just going to put an under root sign over here and just work this out. And that it should be m square s minus 2 under root. And the square root is going to get rid of the squares over here. So ms minus 1 is the answer, which is apparently the right unit. So v should be the answer. I don't need to work the other questions. You can clearly see that if we look at B, the under root sign is not there, so we would be getting the units of, for B, for example, the units would be meter square ms minus 2. That is wrong. That is not for velocity. So this cannot be true. Same for all these other values. So let's just move on to question number 3. And 3 says that shows two vectors x and y drawn to scale. Okay, they are drawn to scale completely. Which diagram best represents the vector z? Okay, so looking at the equation, we can see that x is actually the resultant vector. So I'm just going to put two arrows over here and work out that this is going to be y, right? So y is actually kept positive. So let's just go with this direction. Let's just keep it here. And then z should be, I'm just going to represent z with this line over here. So this is actually z. And the problem is that z is actually in the wrong direction. So that is why there is a minus sign over here. So it is going to be facing this way. And if we look at this thing, this is the start of the resultant vector, and this is the end of the resultant vector. Okay. So there are two paths that can be taken to reach the end point. One path is directly following the resultant path. Okay, so that works out, but there is another path. We can go around this way. We can follow this path as well. So this is actually y. So I'm just going to write y over here. Oh my God. I have to use a different brush. So this is going to be y. And if the route that is taken, which is actually from here to here, if you are moving this way, y is in the correct direction, so y is positive, but z is actually moving this way from here to here. But the vector is actually, but the vector signifies that we have to move this way. So we need to reverse this sign. So this is the correct direction that is selected, and that should give us a negative value. So looking at this diagram, it has to be A. See, okay, so we are just going to move on to the next question. Okay, the student intends to measure accurately the diameter of the wire known to be approximately 1 millimeter and the internal diameter of a pipe known to be approximately 2 centimeters. Okay, so the first thing, the most important point is that it is supposed to measure the internal diameter, so we have to use calipers for our pipe. That is the only way. So calipers for the pipe. And the student intends to measure accurately. If we are going to measure something accurately, if we're going to be measuring something accurately, give me a minute, guys. Give me a minute. Okay, so I'm back, and we happen to be working with calipers, and then we have to find the diameter of a wire known to be approximately 1 millimeter. So this is actually very small value. So the best way to accurately measure it, we use a micrometer. So C is going to be the right answer. Anyways, the next part. Hey, give me a minute, guys. Okay. The power P dissipated in a resistor of resistance R is calculated using the expression P is equal to V square over R, where V is the potential difference across the resistor, and the percentage uncertainty in V is given as 5% and R is 2%. What is the percentage uncertainty in P? Percentage uncertainty in P. So what we are going to be doing is that looking at this diagram over here. So yeah, we are going to be working this, but first of all, let me just tell you one thing, that whenever quantities are multiplied or divided, we always have to add up the percentage uncertainties. We do not work with absolute uncertainties. We can also work with fractional uncertainties, but percentage uncertainties is the best way to go. So let's just look at this thing. The percentage uncertainty V is already given to us and R is already given to us. So this is going to be a piece of cake. So total percentage uncertainty in, okay, I'm just going to write percentage uncertainty in P should be equal to, we have a square here, so that means the percentage uncertainty in V needs to be doubled. V is actually 5%, so 2 multiplied by 5%. And we have the percentage uncertainty in R as 2%, so this is going to be 2. So this is going to be 10 plus 2, and that should be 12%. Okay. So D should be the right answer. Let's just move on to the next part. The velocity time graph for an object of mass is shown. What is the resultant force acting? So F resultant is actually equal to mass into acceleration, but the acceleration is missing, but we can find it out using this velocity time graph. Okay. So the acceleration can be found using this graph. I'm just going to use the extreme values over here. So this coordinate is actually 15 comma 12 15 comma 12, and this is actually 0 comma 3. So 12 minus 3 divided by 15 minus 0, and that should give me a value of 0.6 meter per second squared. This is the acceleration, right? So the resultant force F should be equal to mass, which is given to us as 2.5. So 2.5 multiplied by zero point 0.6 should give me a value of, let me just use my calculator, and that is going to be 2.5 multiplied by zero point 0.6, and that gives me a value of 1.5. So 1.5 should be the right answer. Let's just move on to the next part. Which statement follows directly from the Newton's first law? Let's first of all recall the Newton's first law. It says that if an object is in constant motion, if it is in uniform motion, or it is actually stationary, you require a resultant force to change that. Okay. So, which statement follows directly from Newton's first law? A body remains at constant velocity unless acted upon by a resultant force. So, that should be the right answer. So, let's just read the other options as well. A satellite in circular motion about the Earth has a constant velocity, so that cannot be from the Newton's first law. A water drop leaving a spinning umbrella travels at a constant velocity, so that is also not a part of the first law. The force acting on an object is equal to its change in momentum. That is actually Newton's second law. So this cannot be the right answer. So this must be wrong as well. So A is the only one left. Question number 8. The resultant force causes an object to accelerate. What is equal to the resultant force? That should be the change in momentum per unit time. So C should be the right answer because this is something that I have taught you very well. Anyways, let's move on to the next one. Question number 9. A skydiver falls from an aircraft that is moving horizontally. The vertical component of the velocity of the skydiver is V. The vertical component of the acceleration is A. Which row describes V and A during the first few seconds after the skydiver leaves the aircraft? Just upon disembarking from the aircraft, the initial velocity is going to be 0, and the acceleration should immediately be at its maximum value. There is air resistance. Okay. So as the skydiver starts falling, the velocity would increase at a decreasing rate, but the acceleration would start decreasing from its max value. So the option is going to be V should be decreasing, V should be increasing, sorry, and the acceleration should be decreasing. So D should be the right answer. Okay. This one is a question that is worth doing. Two gliders are traveling towards each other on a horizontal air track. Glider P has a mass of this and is moving with a constant speed of 1.2. You can read the parameters here. And similarly, a glider Q is actually moving in the opposite direction and they're about to collide. It has double its mass, okay? The gliders have a perfectly elastic collision. What are the speeds of the two gliders after the collision? Our target is to find after the collision, but the important statement is that this collision is completely elastic in nature. If this collision is perfectly elastic in nature, we can use the law of restitution to answer this question. The law of restitution states that relative speed of approach must be equal to the relative speed of separation. So if we look at this diagram, they are approaching each other, right? So visually they are approaching each other. So their velocities will, their acceleration should directly, I mean, sorry, their speeds should directly add up, and that should be 3 meter per second. So immediately after impact, after the event where they collide, the law of restitution says that the combined speeds would also be 3 meter per second. So if we look at the 1.2 and zero point 0.6, their combination can never form 3 meter per second, so this cannot be true. Similarly, for B, their combination can never form 3 meter per second, but yeah, C can form the combination, and D can also form the combination can form 3, right? So we need to decide between the two which one holds. Okay, so let's just look at, first of all, let's look at C. The speed of P after collision is actually 2.8 and the speed of Q is 0.2. So we need to verify this fact using the kinetic uh, energies. And for that, we need to find the initial kinetic energy because we know this fact. For elastic collisions, the kinetic energy must also be conserved. The total kinetic energy must be conserved. So let me just find the total kinetic energy before collision. And that is going to be 0.5 multiplied by 3. This is before collision. Okay. So 3 multiplied by 1.2 and 1.2 square. Sorry, my mistake. Half multiplied by zero point 0.3 multiplied by 1.2 square. So the kinetic energy of the first option, sorry, the first glider before contact is actually 0.216 joules. So what about the other one? Actually, I'm going to be just, skipping over this. How about we just find the total kinetic energy of before collisions, and rather than writing it individually. So let's just do it. What you have to do is that you have to find the kinetic energies of individual gliders and directly add them together. So I'm just going to be using a calculator for that operation. So half into point 0.3 multiplied by the velocity of the first glider is actually squared, and plus I'm just going to be adding 1 divided by 2 plus 1 divided by 2 into zero point 0.6 multiplied by 1.8 squared. So the total kinetic energy before collision is actually 1.188 joules. So we need to verify if we are getting the same answer after the collision. So let's just check C first. Let's just check C first. So immediately after contact, the velocity of P is actually 2.8. So 1 divided by 2 multiplied by zero point 0.3 multiplied by 2.8 square plus 1 divided by 2. Okay, so I just made a mistake here. So I'm just going to be doing the calculation again. And that is going to be 1. Okay, I'm just going to do it directly. 0.5 multiplied by zero point 0.3 multiplied by 2.8 squared plus 1 divided by 2 multiplied by zero point 0.6 multiplied by. Okay, I think I made a mistake. Made a mistake. I was just reading this again. So I'll just do it directly over here. Let's just write it down. Sometimes writing is the best way. EK after collision using C option is going to be half into mass is 0.30. So that is why I'm against using directly a calculator. So let's just write it down. So that is going to be 2.8 squared and plus we are going to work this out. So 1 divided by 2 multiplied by the mass 0.60, but the velocity of Q is actually 0.2. Remember this thing, I'm not using signs for velocities over here because apparently we're just finding energy. So energy is a scalar quantity. So now I can do it safely. 1 divided by 2 multiplied by zero point 0.3 multiplied by 2.8 squared. And that is going to be plus 0.5 multiplied by zero point 0.6 multiplied by zero point 0.2 squared. So I am getting the exact same answer as this. So 1.188 joules again. That means this completely matches this value that was before collision. So C has to be the right answer. You can also do it for the other option, but that will obviously not give you the same answer as this. So D cannot be the right answer. Let's just move on to the next question. Okay, so this one is an interesting question. Let me just read it. An object of weight W is suspended from a Newton meter. When the object is completely immersed in water, the Newton meter reads P. When the object is completely immersed in oil, the Newton meter reads Q. So, what is the ratio of the density of oil to the density of water? Well, let's just look at the first diagram. The tension is actually P, and there is always going to be an upthrust force, so U, and there is going to be a weight, which is downward, W. So if they are completely the Newton meter, so we are assuming we know this fact that they are in equilibrium. So this is going to be the what is the ratio of the density of oil? So the equation is U plus P is equal to W for the first case. And let's just do the same thing over here. So this is also going to be U plus Q. This is equal to W. Okay. So let's just construct an equation in terms of the upthrust involved. So upthrust is actually U is actually W minus P and U is actually W minus Q. Okay. So Q capital because it is given as capital over here. So I'm just going to keep it as capital. That does the first part. But then but if you notice the question, it is about the ratio of the densities of the oil. But you already know this, that the force upthrust, or in fact UP, is actually equal to rho GV. So yeah, it is actually directly proportional to the density as well. You can see that UP is directly proportional to the densities. So density of oil, if it is directly proportional, we can just go for this option. I mean, like, we can keep W minus Q on the top and W minus P at the bottom. And that should give me the ratios of the density of oil over the density of water. Let's just match this. And we have this option D over here. So this is done. Let's just go for the next option, which next question, which diagram shows a couple. Well, if you look at this diagram, the couple is a moment, the torque of a couple is actually equal to the product of one of the force and the perpendicular distance between two forces which are exactly in opposite direction and completely parallel. Okay, so let's just look at this option. First of all, A, which diagram shows a couple? It actually shows a couple over here because this is F, and then we have a perpendicular distance. So A should be the right answer. B cannot be the right answer. C is obviously wrong, and D, there is no couple over here. That there's just a moment over there. Okay, an object of weight 120 Newton. I'm just going to pause for a bit and work this out later. So I'm back with this question. An object of weight 120 Newton is supported in equilibrium by two springs as shown. Okay. So we happen to have this diagram over here. What is the tension T1 in the left-hand string? This is in equilibrium. So that means let's just mark this as T2. And this is actually the weight. And all these forces form a closed triangle. But then again, I'm just not going to be using the closed triangle method. I'm just going to use the idea that the upward force, the combined upward force must be equal to the combined downward force, or the forces on the right hand side must be equal to the forces on the left hand side. So the first target is actually to find, we need to find T2, but for that we need to work this out. Okay, so we are going to be forming equations and we are going to work this out. Let's see. The first equation is going to be, we are going to be resolving T1 vertically and also T2 vertically. So we are going to be resolving these two forces and adding them together. So this is going to be T1 sine 70 degrees plus T2 sine 20 degrees, and that should be equal to 120 degrees. Sorry, 120 newtons. That is going to be 120 newton. So this is the first equation that I got. How about a second equation? Let's just resolve it in the horizontal direction. So this one and this one. And if we are going to be doing, we are going to be resolving T1 and T2 only. So T1 cos 70 degrees should be equal to T2 cos 20 degrees. So this is equation number 1 and this is equation number 2. So this is equation number 1. And we need to combine the two to get T1. T1 is our target. So obviously I'm going to make a substitution in place of T2. So T1 sine 70 degrees plus, I'm going to make a substitution over here by substituting this T2 over there. So this is going to be T1 cos 70 degrees divided by cos 20 degrees and then multiplied by sine 20 degrees. And that is equal to 120. So we're just going to solve this equation and we'll be done. And I will be using a calculator. So I have the calculator with me again. And this is going to be 120 minus, in fact, I cannot minus at the moment. First of all, I'm just going to be taking T1 as common. So this is going to be sine, I'm just going to write it down. Sine 70 plus cos 70 divided by cos 20 multiplied by sine 20 degrees, and that is equal to 120. So okay, so first of all, I'm going to be solving the left hand side first. So sine 70 degrees, don't forget the degree signs over here, it is an important practice. Sine 70 plus cos 70 divided by cos 20 multiplied by sine 20, and we find a value that is equal to 1.28. And so 120 divided by answer gives me a value of, let me just do it again. So let's just recheck everything. So T1, first of all, I'm just looking at the first equation, T1 sine 70, sine 20, that is correct, and that is equal to 120. And similarly, right-hand side is cos, so that is obviously that is correct. And when I made a substitution over here, so that is going to be T1 cos 70 divided by cos 20, that is correct. Everything seems to be correct. So I took T1 as common, and let's just look at this again. Sine 70 plus cos 70 divided by cos 20 multiplied by sine 20. So this gives me a value of whatever, and I'm just going to divide this by, I'm going to keep it as the denominator for 120. So 120 divided by answer, and that gives me a value of 112. So T1 is actually equal to 112.7 Newton. So 113 should be the right answer. Anyways, let's just move on to the next question. In a large container in an oil refinery, three oils of different densities are mixed. No chemical activity occurs. The mixture consists of whatever. What is the density of the mixture? Our target is to find the combined density. So density is going to be total mass over total volume. Total mass over total volume. And for that thing, we are going to be adding the total masses together. So total mass should be 1200 plus 1500 plus 4000, and that gives me a value of 6700 kg. And we're going to divide it by the total volume, so we can find the volume using density is equal to mass per unit volume. So volume is equal to mass per unit density. So we need to find the individual volumes first, and I'm just going to input the values directly. So 1200 divided by 1100 plus 1500 divided by 860 plus 4000 divided by 910. Okay, so this is the combined volume. So 6700 divided by brackets, and I'm going to be doing this 1200 divided by 1100 bracket close plus 1 plus brackets 1500 divided by 860 bracket closed plus 4 plus brackets 4000 divided by 910 bracket closed, and we also use another bracket for that value, and I'm getting an answer of 926.6. So this should be 927. A should be the right answer. An electric motor produces 120 watts of useful mechanical output power, the efficiency of the motor is 60%. Which row is correct? Okay. If 120 is the useful power output, this is actually equal, the efficiency of the motor is 60%. So this should be 60%. We can go for 100% to find the input. So that should be 100 multiplied by 120 watts. 100 multiplied by 120 divided by 60, and that gives me 200 watts. So this or this could be the right answer. And if we look at this thing, so 200 minus 120, 200 minus 120 gives me the waste energy. Waste energy is actually 80. So D should be the right answer. This was a piece of cake, basically. Let's just look at this question. Okay. This looks like a question from A2. My God. A fixed amount of gas undergoes a series of changes to its pressure and volume. In two of the changes, no work is done by or on the gas. This is basically an A2 question. How is that possible? In one change, work is done by the gas on its surrounding. Okay. In another change, work is done on the gas by its surrounding. Okay. During the change, when work is done on the gas by its surrounding, how much work is done on the gas? Okay. So we know that work done by gas is actually equal to P delta V, which means pressure, constant pressure, and there should be a change in volume. And we can see the volume is actually changing for two movements over here. The volume is changing over here, and the volume is also changing over here. And at the first top one, the volume is actually increasing. So that means the gas is doing work. But in the last option, that is the bottom one, we see that the work is being done on the gas. No work is being done for these two values because the volume doesn't change. So let's just work out this one over here only. So the change in volume is actually equal to, this is 5 and this is actually 2. So the change in volume is 5 minus 2 multiplied by 10 raised to power minus 4 meter cube. And the pressure is actually fixated at 1 into 10 raised to power 5 because we need to find what is the work done on the gas, right? So work done should be equal to P delta V, and the constant pressure is 1 into 10 raised to power 5 multiplied by the change in volume, that is 5 minus 2 bracket close into 10 raised to power minus 4. This should give me the work done on the gas, and that should be 1 into 10 raised to power 5 multiplied by brackets 5 minus 2 bracket close multiplied by 10 raised to power minus 4, and that gives me 30 joules. So C is the right answer. Anyways, let's move on. An object traveling with the speed of this has a kinetic energy of this. The speed of the object has increased to 40 meter per second. What is the new kinetic energy of the object? Well, the thing is, what we can do is that, okay, what is the new kinetic energy of the object? We can use this. EK is equal to half mv square. We can easily find the mass from the first part and then substitute it and recalculate it again, or we can use a different method. The different method is that we know this fact, EK, the mass is actually constant. If this is constant, oh my God, if the mass is actually constant, this is also a constant. So we can see that EK is directly proportional to V square. We can work this out. This is one way to do it. So let's see. The EK is 1500. The kinetic energy is 1500 joules, which is equal to 100 square. sorry, 10 square. So let's do the same thing for 40 square, and that should give me the kinetic energy directly. Just cross multiply it. So this is one way to do it. This is very, very fast way to do it. Square multiplied by 1500 divided by 10 square. So this gives me 24,000 joules. Or you can resort to working it the longer way, that is, you first find the mass using the very first statement, use the same mass to recalculate the kinetic energy again. Or you go for my method, which is way faster than anything else. The engine, I'm so sorry. The engine of a car exerts a force of 600 Newton and moving the car 1 kilometer in 150 seconds. So so kilometers must be converted into 1000 meters, and in 150 seconds. What is the useful power output? Well, the useful power output is actually work done divided by the time taken. So that should be the power. Work done is actually force into distance moved, that is 1000 meters, divided by the time taken as 150. So 600 multiplied by 1000 divided by 150, and that gives me 4000 watts, which is equal to 4 kilowatts. So B should be the right answer. Let's just move on to question number 19. An extension force graph for the spring is shown. What is the spring constant of the spring? We know this fact, the F load is equal to K times the extension. So K should be the load applied over the extension. If we look at this thing, we can easily find it out using one of the values over here. Just use this. So this is the actually the inverse gradient. So K should be equal to 6 divided by the extension 15 into 10 raised to power minus 2, because I'm converting centimeters into meters, because the answers are given as Newton per meter. So 6 divided by brackets 15 into 10 raised to power minus 2, bracket closed, and that gives me 40. Okay, this one. The wire is extended by a force. The graph shows how the extension of the wire varies with the force applied. Initially, a force W, this is W, gives an extension D. Okay, we can see the D over here. The force is then increased to 2W. Okay, so we go for 2W. This increases the extension to 2D. Which area of the graph represents the work done by the force when the force increases from W to 2W? Okay, so we need to work this out. So, guys, for this particular question, we need to understand, if it were a force extension graph, normally it is like this. The area under the graph gives you the work done. So, for this particular question, the work done is going to be on this side, right? But the question tells me that when the force increases from W to 2W, so that means this is W to 2W. So that means we need to concentrate our attention on this area only. So this area is actually TMRS, and TMRS is also found here. Be careful, this is the extension, it is the force extension graph. I mean, this is the extension force graph, so the axes are flipped. Anyways, Next part, the transverse wave on a rope has a wavelength lambda and period t. The graph shows how the variation of the displacement of the particles of the rope with the distance in the direction of the travel of the wave at time t is equal to 0. Okay, so the particle x is already labeled to us, and this is time 0. Which graph shows the variation of the displacement of particle x with time t? Well, since this is a transverse wave, the particle will simply move up and down, right? The displacement is going to be initially, let's just, as I taught you guys this idea that we happen to have, okay, let's just be done with it. There is a rat under the carpet idea. Let's just assume that there is a rat over here. This is basically the rat. I'm just going to draw this rat again. I need to turn this tablet around to work this out. So basically, the rat is like this. It's a fat rat. And this travels. Okay. So this is the rat that is actually traveling under the carpet. And that carpet is also upside down, right? So the idea is that if the wave is going to be traveling this way, the displacement is initially going to be in the negative direction, right? Then it moves negatively, negatively, and eventually it reaches this position, and then this x point will tend to go up after that. So immediately at position x, there is since it is the mean position. Let's just look over this thing. This is the displacement distance graph. So at x, the particle must be moving down. At x, the x should be moving down. Which graph shows the variation of displacement? It should be moving down. And the displacement increases, and then it, let's see. It must go down. So this cannot be true, so B cannot be true, but let's just look at C option. It definitely goes down and then it reaches the turning point and then it returned back to its original displacement, and after that it tends to move up. So that means this part actually represents, let me show you this idea. I'm just going to be using this. So this part actually is represented by this movement over here, right? So this is the movement. And immediately after that, the particle will actually, yeah, that is correct. That is correct. That is correct. So that is absolutely correct. So it means C should be the right answer. It means C should be the right answer. C should be the right answer. Or let's just restudy this diagram again once again. It's like this. Initially, x is going to move down. Let's just erase this part first of all. X will tend to move down. It will stop at this position and then it will go up. So that is kind of being displayed over here. The displacement is initially negative. It remains negative for the entire movement, and then when another wave strikes it tends to go up. So C is definitely the right answer. So this entire movement, let me just show you this thing. This entire movement from here till this position and then to this position is actually represented by this area, or sorry, this shaded line, right? And immediately after that, you can see a positive wave hits the point X. So it is going to be represented by this curve after that. So yeah, C is the right answer. Which statement about all types of transverse waves is correct? They all have the same speed. Not necessarily. They all have vibrations that are parallel to the direction of propagation of energy. That is only for longitudinal wave. They can all form stationary wave. In fact, all transverse wave and all longitudinal waves can form stationary waves. So this cannot be true. Um, they can all travel through a vacuum. Yes, transverse wave can all travel through a vacuum. So D is true. Source S emits a microwave with a constant amplitude. The microwaves hit a metal screen P and are reflected. Okay, a stationary wave is formed between S and P. So we know that there are going to be series of nodes and antinodes between the two, between S and P. The wavelength of the microwaves is much smaller than the distance between SP. Okay, the wavelength of the microwaves is much smaller than the distance between S and P. So we will have multiple, wavelength. If the wavelength is smaller, so that means we would have multiple positions of nodes and antinodes. So what happens to the amplitude of the signal detected by Q? So detector Q is moved at a slow constant speed from S to P. Decreases steadily? No. Increases and decreases regularly? Yes. B should be the right answer. The siren of a moving car emits a sound wave with a frequency of 440 hertz. This is the source frequency. So Fs, a stationary observer hears the sound of frequency this. Since this is the observed frequency and it is larger, so that means the police car is actually traveling towards the observer. The speed of the sound in air is this. What could be the speed and the direction of the movement of the car? One fact is that it is moving towards the observer because the observed frequency is actually larger. So this is the correct answer, but we need to select one of the options. So we need to find it out. So F observed is equal to FSV over V plus, in fact, we are going to be using a negative sign here because the observed frequency has increased. So we need a negative sign in the denominator so that the value becomes smaller. So for the frequencies to rise. So observed frequency is actually 494. The source frequency is 440. And the speed of sound is actually 340 divided by 340 minus Vs. Our target is to find Vs. So I'm just going to be using a calculator directly to find this out. And that is going to be 440 multiplied by 340. And that is going to be, I'm just solving it directly. So if this goes on the left hand side, let me just show you this working. This is slightly problematic working. So 494 multiplied by 340 minus 494 multiplied by Vs, and that is equal to 440 multiplied by 340. So I've done the part where I just multiplied 440 by 340, and I'm going to be subtracting this by 494 multiplied by 340, and then I'm going to be dividing this by the negative of 494, and this gives me a velocity or speed of 37. So A should be the right answer. An electromagnetic wave has a wavelength of 138 picometer in a vacuum. To which region of the electromagnetic spectrum does this wave belong? Well, I'm just going to copy paste the table that I'm going to be using. This is a table that needs to be memorized. So let's see, picometer. Pico means 138 into 10 raised to power minus 12. So we need to make sure this is actually given in to one. So we are just going to move this decimal place over here. So that means we have divided it by 100. And if you're dividing it by 100, so I'm just going to multiply it by 100 over on that side. So 1.38 into 10 raised to power, uh, 10 raised to power minus 10. Okay, so this is the wavelength. And we need to find which region is this. So radio wave, let's look at radio waves first. Radio waves is actually uh, starts from 10 raised to power minus 1 and it goes beyond 10 raised to power 6. So this cannot be radio waves. How about microwaves? No, microwaves is also not an option. Visible light, C, visible light is actually 10 raised to power minus 7 and it remains in this region, so this cannot be true. Obviously, then we are left with X-rays, and you can clearly see that X-rays lies between 10 raised to power minus 10 and it goes all the way smaller to 10 raised to power minus 16. So, uh, sorry, 10 raised to power minus 8 to 10 raised to power minus 13. So it lies between this region. So X-ray is the right answer. Okay, I was looking at gamma ray, so no, it is X-rays basically. Okay, so this makes sense, and this is done because 10 actually lies in this range over here. So this is going to be X-rays. So D is the right answer. Okay, this is a question. Two wave pulses are traveling towards each other on a long rope. The pulses have the same amplitude and wavelength and are traveling at a speed of 0.5 meter per second. Okay. The diagram shows the rope at time t is equal to which diagram shows the rope at time t is equal to 3 seconds. So let's just calculate the distance traveled in when the rope is actually when the wave is actually traveling at zero point 0.5 and for 3 seconds. So zero point 0.5 multiplied by 3 is actually equal to 1.5. So if we are standing over here, let's just draw this wave. It's going to be like this, right? This is a wave. And if I select the starting of the wave, it actually travels 1.5. So this is 7. So this is 0.5. This is actually 1. So 1.5. It is going to lie somewhere over here then. Okay. So this is the right wave that has traveled towards this side. And what about this one? Let's see. Well, in the examination, you will have to draw this on your own. Well, that is not a difficult idea. I can move it around over here. And this also tends to move towards the right. So yeah, if we start from this position, so this is actually 1.5. So this is 0.5, this is 1, and this is 1.5. So you can clearly see that the two waves are actually superposing constructively. So the amplitudes are going to increase, and C should be the answer. Okay, so this is done. Anyways, let's just look at this question. Water waves of wavelength lambda are incident normally on an obstacle with a narrow gap. The width of the gap is equal to lambda. The waves from the gap emerge over an angle theta as shown. The gap is slowly widened. If this gap is actually increased, what changes, if any, occur to theta and the wavelength of the emerging waves? Well. The theta is the spreading. Actually, we know this fact that the idea is diffraction. Maximum diffraction is seen when the size of the opening is comparable to the size of the lambda, which is the wavelength. So if you are going to open this, the the spreading of the waves decreases. So this theta will tend to decrease. Okay, so theta will decrease. Theta is going to decrease and wavelength will remain the same. So this and this is the right answer. A is the right answer. Okay. Light of wavelength 720 nanometer from laser X is incident normally on a diffraction grating and a diffraction pattern is observed. Okay. Light from laser Y is then also incident normally on the same grating. The third order maximum due to laser Y is seen at the same place as the second order maximum due to laser X. What is the wavelength of the light from laser Y? Let's just do this question. So yeah, Monochromatic light, sorry, a light of wavelength 720 nanometers from a laser axis incident normally, hey, give me a minute, guys. Okay, no, is incident normally on a diffraction grating and a diffraction pattern is observed. Okay, so we are going to be using an equation known as D. Just give me a minute, guys. It is actually going to be, listen, guys. Oh my God, I'm just seeing some messages in front of me. Just give me a minute, guys. Okay, it's gone. Okay, so let's just look at this thing. So I'm going to make a selection again, but it is stuck for some reason. Oh my God, I need to work this out again. So I'm just going to pause this. Let's just pause this. And something just went wrong over here. So, task manager, why am I getting this option? What just happened? Is it working now? Yes, it is working. Oh my God, took forever. This is Windows. My God, Windows can be so unstable, so unreliable at times. My God, I'll just include this in the video. I won't remove anything. So it's just part of what goes through while recording stuff. I was just worried I would lose everything. D sine theta is equal to n lambda is the equation that we're going to be using, where D is the number of lines per meter or whatever. Sine theta is the angle with the normal, and n is the order number, and lambda is the wavelength. Okay, light of wavelength, this from is incident normally on a diffraction grating, and a diffraction pattern is observed. Light from laser Y is then incident normally on the same grating. The third order maximum due to laser Y is seen at the same place as the second order maximum due to laser X. Okay, so let's just keep it as D sine theta is also incident on the same. The third order from laser Y is seen on the same place as the second order maximum due to laser X. So this is actually second order. So lambda is actually 720. Let's just keep it as nanometer. We'll most probably will get rid of it. Okay. So what is the wavelength of the light from laser Y? Okay. So we need to find that value. So everything remains the same. The angle remains the same, but then we have another equation. So d sine theta is equal to 3 times lambda. I'm just going to call it lambda y. Okay. So all we need to do is just divide the two and work this out. So this is going to work very easily. So if you're going to be dividing these two equations together, if you're going to be dividing these equations together, so that should be equal to d sine theta is equal to 2 times 720 nanometers. I'm not going to lose this. This is nanometers divided by d sine theta again, and that is equal to 3 times the lambda y. So these cancels out. So this is going to be 3. I'm just going to write it down. Lambda y is actually equal to 2 times 720 divided by 3. The answer will directly come in terms of nanometers. So this is going to be 2 multiplied by 720 divided by 3, and that gives me 480. So A should be the right answer. A should be the right answer. Anyways, let's move on to the second, the question number 29. Okay, this is slightly, I'm just going to erase this, okay, so that I don't mess up this question. 29. Monochromatic light of frequency f is incident on a diffraction grating of line spacing d. Okay, so we have the spacing d. The speed of light is c, which expression can be used to determine the highest order of intensity maxima produced by the grating. Highest order of intensity maximum. So we need to work this out. Let's just look at this thing. N is the order number. The monochromatic light of frequency F is incident on a diffraction grating of line spacing D. Okay, line spacing is given to us as D. So d sine theta is equal to n lambda, and apparently the highest order is produced when sine is 90. So d sine 90 degrees is equal to n lambda, but we need to work this out in terms of the frequency. So d sine theta should be equal, but in fact, I'm just going to remove this sine theta altogether because this is actually 1. D is equal to n lambda should be equal to uh, speed of light is c is equal to frequency into lambda, so lambda is equal to c over f. So this is going to be c over f. So n is equal to df over c. So n is equal to df over c, so b should be the right answer. Okay, this is done. Okay, let's just look at this thing. Metal plate of uniform thickness is connected to a cell as shown. Okay. Electrons move clockwise around the circuit. Clockwise is definitely in this direction. Moves. Which statement about the metal plate is correct? The average drift speed of the conduction electrons decreases as they move from right to left. No. Apparently, we know this fact. I is equal to NA VQ, where V is the drift velocity. So this is the velocity, drift velocity of the charge carriers, and I is the current, and A is the area. Okay, this is the current. But we can see that area and the velocity are in an inverse relationship. So the idea is that over here, the drift velocity actually increases this way. It increases in this direction. The drift velocity should increase in this direction. The average drift speed of the conduction line decreases as they move from right to left, so this is wrong. The average drift speed of the conduction electron increases as they move from right to left through the plate, that is correct. The number density of the conduction electrons decreases. No, this number density would remain constant because the material has not changed. Okay, so this is wrong. So B should be the right answer. Okay. The diagram shows the direction of the current in a metal block. Okay. The charge carriers enter the block through the phase PQRS. Okay. The number density of charge is carriers is N. Each charge carrier has a charge E. The average drift speed of the charge carrier is V. Which expression gives the current in the block? So current in the block is equal to NAVQ. So I is represented by I, and N remains the same, multiplied by the area is actually Y multiplied by X. So Y multiplied by X, and the area is Y multiplied by X multiplied by the speed V, and the charge, and the speed of the charge carriers is V. Give me a minute. And what we are just going to represent the charge as E then, because it is given by E over here. So the answer should be NYXVE. NYXVE. Let's see. NYXVE. So B should be the right answer. Let's just arrange this way. So I'm just going to underline the words EN. Y is present, and ENY, and VX is also present. VX is present, definitely, yes. So this is B should be the right answer. 32. What could not be used as a unit of potential difference? Okay. Potential difference. Okay, this is ampere. This is I into R. So V is equal to IR. So this is actually correct. Newton Newton per meter per coulomb. This one is interesting. Normally, potential difference VPD is work done over charge. So work done should be force into distance. So Newton meter per coulomb should be the right answer. So this is not the unit. B is directly the answer. This one is correct because this is power per current, and P is equal to IV. So V is equal to P over I is definitely correct, and obviously all other are correct. So B is the wrong answer. Which graph could show how the resistance R of a filament lamp varies with the applied potential difference as V is increased to a normal operating PD? So the resistance will tend to increase. Yes, definitely, because it will warm up. And because the temperature is going to increase, so the resistance should increase. And it does not start from zero. It does not start from zero because it already has resistance initially. And so the only best option that I can see is actually A. Kirchhoff's two laws for the electric circuits can be derived by using conservation laws. On which conservation laws do Kirchhoff's law depend? Kirchhoff's first law is the charge. Depends on the conservation of charge. That is correct. Kirchhoff's second law depends on the conservation of energy. So B should be the right answer. This was easy. Let's look at this. The diagram shows a circuit. Which statement about the circuit is not correct? Electromotive force. Okay, this always creates a problem. Not correct is always the problem. Okay, so not means that we have to find something that is a lie. Electromotive force is the energy transferred per unit charge. That is actually true. That is because electrical energy is transferred per unit charge. That is correct. Energy transferred is from chemical potential energy in the cell to other forms when the switch is closed. No, that cannot be true. The about the circuit is not correct. Okay, about the circuit energy is transferred from the chemical potential energy in the cell to other forms when the switch is closed. That is also true, by the way. That is also true. Electromotive of the cell is greater than the terminal potential difference when the switch is closed. That is also true because we happen to have internal resistance over here signified by this resistance. So when the switch is open, the voltmeter measures the electromotive force of the cell. It does not measure anything. So D is definitely not correct. Okay. So let's just move on to question number 36. The diagram shows a circuit containing 4 voltmeters. The readings on the voltmeters are V1, V2, V3, and V4. All the readings are positive. Which equations relating the voltmeter readings is correct? V1 should be equal to V2 and V2 should be equal to V1 plus V4, V3 plus V4. So let's just look at this thing. So V1 is equal to V2 plus V4. Nope. V1 is equal to V2. No. V2 plus V3. V2 plus V3 is equal to V4. Definitely not. Okay, V3 plus V4. V3 plus V4 is equal to V2. We can rearrange this thing. So V3 plus V4 is definitely equal to V2. So D is the right answer. D is definitely the right answer. This was interesting, tricky. The network consists of 3 ohm resistor and two 6 ohm resistors as shown. The potential difference across the network is 4 ohms. Sorry, 4 volts. What is the current through the 3 ohm resistor? This is basically a baby level question. So first of all, let's find the voltage across this part. I can simply use I'll just approach this question in a way that is very, very direct. So I'm just going to find this using the potential divider formula. So apparently the potential divider formula is like this. V out across this combination should be, I'm just using product over sum combinations, 3 multiplied by 6 divided by 3 plus 6, and that should give me a combination of 2. So V across 2 ohm, this is actually 2 ohm, the combination is actually 2 ohm. So V across 2 ohm is actually equal to EMF, which is 4 multiplied by 2 ohms divided by the combined resistance of 6 and this 2 ohm, which is actually equal to 6 plus 2. So this is going to be equal to 4 to the 8 divided by 6 plus 2 is actually 8. So the voltage is actually 1 volt over here. So 1 volt is divided is actually equally sorry, it is remains the same on both these resistance over here. So the target is to find the current over here. So I is equal to 1 volt divided by the resistance, which is equal to 3. So 1 over 3 is actually equal to 0.3333 amperes. So C should be the right answer. In the circuit shown, all the resistances are identical and all the ammeters have negligible resistance. Okay. The reading A1 is 0.6 amperes. Let's just write it down. What are the readings on the other ammeters? Okay, so all the resistance are identical. So if we had two resistors over here, the current is actually 0.6. We don't have a resistor over here. My God, how are we going to work this out? So it's like we need to work this out somehow or another. So let's just go over this slowly and gradually. If we have one resistor in a loop, so the current is going to be uh, double this. So this is going to be 1.2 amperes, 0.6. So that is going to be 2 amperes. And if we look at, so we have three resistors over there. So we can find this A2 directly. Let's just work this out as well. A4 is going to be, we have three resistors in this branch. So three resistors would mean if we have one resistor, the value is 0.6. My God. No. I just made a mistake. So if we had 1.2, so 1.2, so, and we have 0.6 when we have two resistors in series. And if we have three resistors in series, the value of the current is going to be further decreased. So A4 should be lower than 0.6. A4 should be lower than 0.6. But let's just work this out. और हमारे पास क्या है इधर? A2 is a big problem. The current actually flows in this direction. So apparently the current is moving this way after this position. So if it goes over there, then we definitely have some current over here as well. And we need to work this out. How do we find it out? So current is actually inversely related to the resistances. I is inversely related to 1 over R. So we can use this relationship. So if current is actually 0.6 and we are getting a value of 1 divided by 0.6. So if 1 divided by 2 basically is because we have 2R over here. Okay. So therefore we can use this 1 divided by 3R should give me a current of, we just cross multiply this thing. So 1 divided by 3 multiplied by 0.6 and divided by 0.5, that gives me an R of a current of actually 2.5. So this is going to be 0.4. So the current here is actually 0.4. So we found it out using this relationship. And if 1.2, okay, so now we can work this out. So A4 is definitely going to be 1.4. So therefore A3, let's just match these values. This is 1.2 and A2 is actually going to be 2.2. So D should be the right answer. Oh my God. Let me just prove it to you guys. If this is 1.2 and this is 0.4, so these are moving this way. So if we add these two together, so wow, this is going to be 1.6. 1.6 is this. So 0.6 plus 1.6 gives me 2.2. So this is done. Michael, this was a good question. Required everything. An unstable nucleus of an element decays by emitting an alpha particle or a beta negative particle to become a nucleus of a different element. By emitting an alpha particle or a beta negative particle to become a nucleus of different elements, definitely yes, the proton number actually changes. The nucleus is also unstable and also emits an alpha particle or a beta negative particle. The nucleus is also unstable, okay. This nucleus, that means one that is formed, is also unstable. The process continues until an isotope of the original element is produced. Okay. What is the minimum possible number of these particles emitted? Now, this is a very, very smart question. Emitting an alpha particle or a beta particle to become a nucleus of a different element. This is also unstable and also emits an alpha or a beta particle. So let's just first of all look at this fact. Whenever we have an alpha emission, this leads to the top number to decrease by -4. That means the mass number decreases, sorry, the nucleon number. I'm just going to represent nucleon number by A. A minus 4, and the proton number is represented by P, so that is P minus 2. This is for alpha emission, and for beta negative, the A number doesn't change, A remains the same, but the proton number increases by 1. So we need to work this out so that we get the same element again. Original element is gained. An unstable nucleus emits the decays by emitting an alpha particle or a beta particle. So let's see if how many number, what is the possible number of these particles emitted. So let's see. If we go for first option, A, is A even possible? Let's see. If I emit a beta particle initially, the proton number is going to increase by 1. But then there is no way I can go back to the original number directly after the first emission. So 2 cannot be the right answer. But apparently, if you look at the three emissions, so let's suppose the first one is actually a an alpha emission. If the first one is an alpha emission, then the proton number decreases by 2. If the proton number decreases by 2, this can be followed by 2 beta negative particles, and that would again make the proton number exactly the same. Think over it. 3 is the right answer. The way is going to be like this. First alpha, followed by 2 beta negatives. If this route is followed, we will arrive at the same element, at least the bottom number, which is the number of protons, will still remain the same. The atomic number won't change this way. You can verify it yourself. The diagram shows the quark composition of four different hadrons. One of the hadrons is a whatever particle. It has a charge of plus E, where E is the elementary charge. Okay. Which hadron could, it's a hadron basically, so heavier particle. Which hadron could E positive particle be? We need to memorize the table for the D charge, the D and the S, and all these charges must be measured for all these quarks over here. So let's just work this out. I'm going to first of all copy paste the table of the quarks here so that we can work this question out. This needs to be memorized by you guys. I'll show you how it's done. So I'm just going to pause this for a minute and come back with the table. Okay, guys, I have the charge with me. The table is given to me as this is the table. Where does this table even go? Why is it not copy pasting? Okay, so apparently I'm going to be reading the table directly from the website. And let's see, why didn't it even copy? Or let's just save this image and I'll just open it somewhere over here. Or let me just use the snipping tool. Just give me a minute. So I'm just using the snipping tool to copy paste this entire table. And let's just work this out. So this is going to be new. Oh my God, it did not work for some odd reason. So new. And let's just go over these charges. So I have everything with me now. And let's just go back and paste it over here. And this time we have the table with us. So I'm going to be using this table. And I'm going to make this table slightly smaller so that we can work this out. Okay. So let's just go over these options. So DD is actually minus 1 over 3. So we need positive charge. So minus 1 over 3 plus brackets minus 1 over 3. And S is the strange quark, which is actually minus 1 over 3. So apparently this can never be positive. Okay, so this is goes to, this is ignored. DSS is again negative, so this does not make up. Up is actually plus 2 over 3. So let's see, 2 over 3 plus S is negative minus 1 over 3. So this is going to be, give me a minute, minus 1 over 3. And we have another minus 1 over 3. So this is zero charge, so this cannot be true as well. So we are left with D option. You can verify directly UUS. So UU is actually 2 over 3 plus 2 over 3 minus S is actually 1 over 3. So let's just do it. 2 over 3 plus 2 over 3 minus 1 over 3 is actually 1. So this makes it happen. Guys, thank you so much for your time. And let's just end this recording. And we will be continuing with more questions later. So, guys, take care.